Okay, so in this next series of videos, we're going to talk about graphing by finding any 2 points. And we're actually going to look at 2 different ways to do this. The first type of problem that we're going to look at is graphing by finding any 2 points. And this means any 2 points that are on the line. There's not a lot of restrictions here. And that can be a little confusing for these problems. So I went ahead and wrote out our steps so you can kind of see what we're talking about. Our first step that we want to do is we actually want to pick a value for x. And this is where it can get kind of confusing because you can pick any value you want. Now, as we go through the problems and we look at examples, we're going to talk about picking a smart value and trying to do numbers that make it easier for us to solve, but we can use any number that we want. Then we're going to plug in whatever value we've chosen on our step 1 and we're going to solve for y. So what we're going to do is pick a value for x, we're going to plug it in and we're going to see what's its corresponding y value, what corresponds with that, so that we can have a point that has both an x and a y value there. And then what we're going to do is just repeat steps 1 and 2 a second time so that we can get a second point. So we'll have 2 points on our line. Okay, so for our first example of graphing by finding any 2 points or any 2 ordered pairs, we have the equation negative 4x plus 5y equals 0. So again, what we're going to do, and I like to do this with a chart, but you don't have to do that by any means. It looks kind of similar to what we were doing at the end of the video for our last section. I like to go ahead and make that XY chart, and again, you get to pick any number that you want to pick for x, anything your heart desires. And so typically, especially when I'm looking at a problem like this, I love the number 0. The number 0 is usually really easy to plug in. It's usually really easy to solve for. It's one of my favorite numbers to use. And then we can pick another number. Now this is where we kind of get some leeway. We could go with 1, 2, -3, -7. What I'm actually going to do, and this works most of the time, sometimes it doesn't, but most of the time if I look over here and I look at the coefficient of my y value, because I know at the end of solving for y, that's the last thing I'm going to have to do is divide by this guy. So if I choose something that I know 5 will divide into, then usually I can get some nice pretty numbers in here. Every once in a while that's not always true, but for the most part it is. So here I'm going to choose the number 5. Because I know 5 will divide into 5. So these are my 2 numbers. I chose them 0 and 5. Again, they don't have to be these. You could have chose 1 and 2, 7 and 8, -10 and 5. One of the things you do want to keep in mind is our graph only goes from -10 to +10, so we do have a little bit of a restriction as far as how big we can go. So we definitely kind of want to keep it a little bit small. So now what we're going to do, now that we've decided our 2 numbers, we now need to figure out what y values correspond to these 2 values we picked for x. So here we're going to take the 0 and we're going to plug it in for x. And we're going to say -4 times 0 plus 5y equals 0. Well, -4 times 0 is just 0. So I have 0 plus 5y equals 0. Well, 0 really doesn't add or subtract anything to the problem, so I can actually just kind of go, hey, that's gone. I don't really need him anymore because he's 0. So I just have 5y equals 0. Well, now I just need to divide both sides by 5, and I figure out that y is equal to 0. So when x is equal to 0, again, this is the value I chose, y is also equal to 0. Now we're going to do the same thing for our second value we chose. We're going to plug in 5 for our x and see what happens. So I'm going to come over here, still using my same equation. So -4 times 5 plus 5y equals 0. Again, I want to go ahead and multiply these together. So that's going to give me -20 plus 5y equals 0. I'm going to add 20 to both sides. So 5y equals 20. And then lastly, I'm going to divide both sides by 5. And y equals 4. So when x is 5, y is 4. Now you notice that when I printed this out, I went ahead and it mirrors what you have in your homework. So here in my boxes, I would plug in 0 for my x, and 0 for my y. Again, I chose x to be 0 and I found y to be 0. And then I chose x to be 5 and I found that when that happened, y was 4. So now I need to do is to graph my 2 points. Well, this point 0, 0, that's just my origin. Remember, that's that point at the center of our graphs where our 2 axes cross each other. And then 5, 4 would be to the right 5 and up 4, so that's my second point. Now the big thing here is I actually need to connect my 2 points because I am actually graphing a line, and in order to graph a line I have to have 2 points, and then I just have to take and connect them. I am a horrible line drawer, so I am going to use a ruler. If you can draw your line straight, that is awesome. But I'm going to use my ruler here, and I have a nice straight line. Notice that when I drew my line, I drew it across my entire graph. I didn't draw it just between the 2 points. And that's a technique that I want you guys to kind of get used to doing, because when we solve problems in chapter 10, or when we solve systems of equations by graphing, we need to have that line going all the way across our graph. Okay, so for our second problem, again, we're graphing a line by finding any 2 ordered pair. We've got our equation here of y equals negative 3x. So again, I'm just going to do my x and y. And again, I'm just going to choose 2 points. I'm going to do 0 because, again, I really like the number 0. And I can really, for this particular problem, because at the end of the day, when I solve for y, I'm not going to be multiplying or dividing by anything. So I can choose any number I want for y. So let's choose 2. Again, just a random number. It's not anything special about the number 2, just a number. So here we're going to plug in 0. And we're going to say, okay, y equals negative 3 times 0. So y equals 0. So again, thinking about our number line, or what we've done here, we've picked x to be 0, and we found that y was 0. We're going to do the same thing and say y equals negative 3 times 2. Okay, well, negative 3 times 2 gives us negative 6. So when x is 2, y is negative 6. Again, as far as when you do your homework, what it's going to look like is you'll have your A and B boxes here. So remember, we picked x to be 0, and we found that y was 0. And then we picked x to be 2, and we found y to be negative 6. And we're just going to graph these 2 points. So again, 0, 0, here's here right at the origin. And then positive 2 would be to the right 2, and then down 6 would be about right there. And again, I'm a horrible line drawer, so I'm going to use my ruler here and connect my points, making sure to go across my entire graph. And that is the line y equals negative 3x. Okay, so again, for our third example, we are graphing a line by finding any 2 points. So we've got our equation here of 7x plus 3y equals 8. I'm going to make my chart here and do x and y. Again, I like 0, so we're going to go ahead and stick with what we know. We got a 0 there. And then we can do just what we did on our previous problem and look at the coefficient in front of our y and say, okay, well, let's do 3 as our second value. Again, if you wanted to use the number 1 or 2 or negative 5, it doesn't really matter as long as you take 2 different numbers for x. So we're going to plug these values in, and we're going to say, okay, well, 7 times 0 plus 3y equals 8. I'm going to be a little bit lazy here because I already know that 7 times 0 is 0, so I'm just going to go, hey, that just goes away because it's 0. So we have 3y equals 8. We're going to divide both sides by 3, and we get that y equals 8 over 3. And I know you're thinking that's a fraction. I really don't want to have to deal with that. Now, when I put your answer into the system, I want you to go ahead and leave it as 8 over 3. I know that seems kind of weird and funky, but if we're graphing by hand, what we can do is go ahead and just divide that out. And 8 divided by 3 would be 2.67, and that's going to give us a better idea of how to graph that. And we're going to have to do a little bit of guesstimation because it is a fraction and a decimal, but as long as we have it in around about the right place, it's going to be fine. Okay, so let's do the same thing for the 3 that we chose earlier. So we've got 7 times 3 plus 3y equals 8. Well, 7 times 3 this time is 21, plus 3y equals 8. We're going to subtract 21 from both sides of our equation. So now we have 3y equals negative 13. And we are going to divide by 3 on both sides. Again, for the purposes of putting our answer into the system, we are going to leave it in that fraction form, negative 13 over 3. But since we're going to be doing this by hand real quick, we want to go ahead and say that this is y equal to negative 4.33. Again, that's just so we can kind of estimate where it is on our graph. So again, for the system, and when you plug your answer in for your A and your B, we picked x to be 0, and we found out that y was 8 over 3. We picked x to be 3, and we found out that y was negative 13 over 3. Again, this value is a positive 2.67, and this value is a negative 4.33. And that's just to help us graph it on our graph right here. We wouldn't necessarily need to do that when we did our homework in the computer. So 0, again, we're not going to go right or left. We're going to go up to 2.67. That's just right below 3. Again, it doesn't have to be perfect. We are graphing by hand, so it can be a little off, but as long as it's in right about the right place. So for the other one, we're going to positive 3, and then we're going down to negative 4.3. So that's just a little bit past negative 4. So 1, 2, 3, 4, and just a little bit past that. And again, I'm going to take my ruler here and connect my dots going across my entire graph. And that is the graph of the line 7x plus 3y equals 8.